multi-area OSPF. Why go for multi-area OSPF? The reason behind it is that if you have a large number of routers and they all share the same topology within the area, any topology change needs to be flooded across the system, and each router in the area needs to calculate new path. This is a CPU intensive task using shortest path first algorithm, and with large number of routers can increase the latency of our network upon topology change. So one of the solutions to this kind of problem is to separate routers so that they don't actually share all the topology, and this is where multi-area OSPF come into play. Within the area, the routers will know each other and all their, let's say, type 1s and 2s, but they will not have to know everything about routes outside their own area. But as long as the router connecting area 0, well, in this design we have to use area 0 as a backbone area, all other areas need to be connected to area 0. That's the constraints in OSPF. There is a way around that, but it's not an elegant solution, and we'll tackle that in a separate video clip. So in my design, what I want to do is I want to remove OSPF from R4 and R5 and recreate that using this design. All the routes, all the connections here will be area 0. This is going to form an area 0, the backbone area. But R4 is going to connect area 4 on those two links, and that is going to make this router the OSPF area border router, ABR. And the same thing here. R5 will be in area 0 here, but the links below here are going to be area 5, which makes this router an area border router in OSPF. Area border router connects area 0 to some other area, and only router 5 knows both areas. Router 1 and 2 won't care if anything goes wrong within area 5 or area 4, because the routers within these areas need to recompute the best path as they share the topology within the area. But outside the area, all we need to know that there is such network as 10120, and we don't care what the relation of that network is to the rest of the system as long as we can reach the router that knows how to get there, which is router 4, area border router. So how do we do that topology? Let me just quickly remove. So I'm going to go to no router OSPF here. Same thing here. And what I'm going to do here, let's just clear the terminal real quick. All those links, 10, 14, 24, and 45 will be area 0. So I will recreate my OSPF here. Network 10, 14, 4 is going to be area 0. 24 and 45. So meanwhile, although those reestablished the adjacency. Now here I'm going to do the same thing, clear the terminal. Router OSPF 1 and network 10, 1, 15, 5 is going to be area 0. And 25 is going to be area 0. And 45 is going to be area 0 here. Now, so area 0 is now established here on those, and do show IP OSPF interface brief. All area 0, do show IP OSPF, do show IP OSPF neighbor. And we're good. So now what we're going to do here is we're going to establish area 4 below router 4, which is those two links. So let's go back to R4 and do network 10, 1, 2, 254. This is going to be area 4 and 3. Now there are no routers to learn to discover there, so it's going to be just links placed, and the show IP OSPF interface brief now. These two links are in area 4. The wait timer is basically waiting for discovering of DR, but there is no DRBDR there. I'll do the same thing on or on 5. So network 10.1.4.254, all zeros, matching the interface will be area 5, and the same will be on area 5, the second link. Now, so what happens? The area 4 and area 5 are connected to the respective routers and making them ABRs, area border routers, which connects area 0 here to some other area, area 4 and area 5 respectively. Let's go full screen maybe here to see a few things about now this design. So I'm going to clear this and I'm going to clear this. So how does ABR manifest in itself with these commands? Let's go for database. Now the larger output here is okay. How do I know the area? This is the router 4. How do I know the router 4 is a multi-area connection? This is an ABR because it has the database for area 0, knows everything about area 0 here, and we have LSA type 1, router LSA, links the LSA, LSA type 2, advertised by DRs, respective DRs in the area, and now we also have a summary link LSA, which is the LSA type 3 generated by ABR, which only advertises network towards area 0, but does not know what the actual relationship of the links is. It's just not necessary to know that, and this way we don't have to don't have to recompute the topology upon advertising new network or network going down. And we also have information about area 4. So this is a separate database here. Area 4 has the link state LSA, which is the LSA type 1, and summary LSA from area 4. So what links are advertised outside area 0? What are we learning and what we're advertising from other areas? We're advertising here, LSA type 3, advertise all the links right here into the area, the reachability to all those networks. And the area 4 has a boundary router, only one here, and that router is router 4, as we can see. Same thing is on R5. We would see the same thing. So this makes this area border router. Now let's see how R1 now determines how to reach the, let's go here. How does R1 know how to reach 10.1.2.0 subnet? Well, it knows that. Let's go to R1, show IP OSPF database. This is an internal router. It's not an area border router. It's an internal router, an internal router for area 0, backbone area. All it knows is everyone in area 0. And it knows that there's a link state LSA type 1, LSA type 2 advertised by DRs within the area, and there's a presence of 2 ABRs, R4 and R5, and these are advertising different networks. R5 is advertising 10.1.4.1.5, and 4 is advertising 10.1.2 and 10.1.3.0 networks. If I look closer at this, show IP OSPF database, let's say summary link, and maybe 10.1.2.0, all we know that the R4 is the area border router, and it is advertising 10.1.2.0/24. We don't know anything more, and we don't have to. As long as we know how to reach R4, and we do because we have LSA type 1 and 2, and we know how to reach R4 inside our own network, that's our gateway towards 10.1.2.0, we are good. So we can as soon if this one is advertising this network, as soon as we know how to get this to this one, and we know how to reach the network. Now this network is now going to be different in the OSPF routing table. Well, one last thing quickly, show IP OSPF, actually show IP route OSPF. All the internal network, so LSA type 1 and 2 are advertised and signified with the O letter. All LSA type 3 are signified with OIA for inter-area router. And that's how we can get to those networks via the next hop device, which is basically the advertising router for that particular route.